Very good evening. We'll start this session. Hope my screen is visible. And my voice is also audible. Yeah. So last two classes we discussed about the basics of electric vehicle and how the electric vehicle and automotive requirements, what is the different aspects of automotive and all. So today we will be moving more into talking about powertrain, what are the components, maybe in detail of components, what is the architecture, what are the features which vehicle should have, why that vehicle will be classified in that particular architecture, where, and these things we will be discussing more. So first of all, we start with the hybrid electric vehicle powertrain, then what are the classification of HEVs based on the features, what are the features we will discuss. Then we move into what is the drivetrain requirement, what is the different architecture of powertrain we have, time permits based on different classification of architectures also we will see. So coming to the hybrid electric vehicle powertrain. So the name itself talks about the hybrid electric vehicle. So here we know that there are two energy sources. So when two energy sources are there, so the propulsion requirement is also like it may be a motor and an engine, or it may be a motor itself may propel, but the conversions will take place. So and the other one is the powertrain. In the powertrain, what are the regular elements or components in the conventional engine? In conventional engine, you will have an internal combustion engine. You will have an exhaust system. You will have a thermal cooling. You will have a battery auxiliary, transmission, and a fuel tank. So these are and a fuel filler. So these are part of your conventional powertrain or conventional IC engine based vehicle. Since we added an extra element called hybrid, then we need to have first hybrid. We need to have an energy source. What is the energy source? If you see from the front to back, then you have to have a battery. When you want to have a battery, then what is the interface between battery? Then there is a propulsion requirement. Propulsion requirement was done from a traction motor. So sometimes generator, because that depends on the different architecture. One may be like parallel and the series. So how those they connect, we will see subsequently in this class. So depends on the requirement. Sometimes you only require a motor. Sometimes you require both motor and a generator. And when you have a battery and you have a motor, so there is some conversion requirement is there. Motor is like an AC motor. Battery output is a DC output. What are those requirements? So those will be coming from a power electronics controller and DC-DC converter. Sometimes this power electronics controller, we can also call it as a motor control unit or an inverter. So different names can also be like this in the literature. So when you have this, then when you power electronics converters comes, there is a semiconductor requirement will be there, semiconductor device. So there will be a heat generated. So to cool that, you may require some cooling system based on that. And especially this battery auxiliary. Battery auxiliaries for the infotainment requirement, for example, for your lighting or your steering or your the multimedia application, we generally go with this auxiliary battery requirement. So this picture was taken from the Department of Energy, and very commonly explains, very neatly shows what are the components placed. And again, there depends on the architecture, how many electrical motors to be used, That will also be a question. Either it should be a 4 electrical motor, or it should be a 2 electrical motors, or it should be only 1 electrical motor. That all purely depends on what and how you are going to use these all components. Okay. So that is one more interesting thing to see. So next is like how do you classify these hybrid electric vehicles? If you see, the hybrid electric vehicles are classified differently, like mild hybrid, hybrid electric vehicle, plug-in hybrid electric vehicle, battery electric vehicle, and FCVs. FCVs. Before mild, there is a micro, and we will also see that. So from micro to mild, mild to hybrid electric vehicle, hybrid electric vehicle to plug-in hybrid electric vehicle, plug-in to battery electric vehicle, then FCV. The electrification means the increase in the battery size and increase in the propulsion capacity will be more. So that's what this picture shows more information. How much is the capacity of your hybridization is happening? Means, for example, your I can say your electric vehicle plugging in electric vehicle and hybrid electric vehicle. You have a difference. How much you want to give what percentage based on that we will also see in our electric vehicle design or design of H and EV, where we talk about in detail what percentage relates to. So these vehicles based on what are the features it requires as a hybrid electric vehicle. So for example, if you see here, there are 4 and there is one more requirement. First one is idling stop. So idling stop is nothing but, so for let us say when your vehicle is propelling on when your vehicle is propelling in a motion, like this, and for now just I have considered simple motion. Then we have seen the other forces which generally acts on the vehicle, right? So when the vehicle is traveling with a constant speed, then there is a way like you can expect after a certain distance a traffic signal. So on this traffic pole, you can see that there is a requirement that the vehicle should stop for a signal. Then during that requirement, you will see that you have to stop the vehicle. Let us say traffic signal is for 30 seconds or 1 minute. You will see that there is an energy consumption when your vehicle is steady state. Though you reduce the gear and you will, but there is an energy consumption in the vehicle. Or the other way, what you will do is you will switch off you will switch off the vehicle and you will switch on. So when you switch off and switch on, there is again you require during the starting a high torque. So power requirement and speed requirement, these will be followed. So during these traffic and go situations, or in an urban condition like buses, where there is a very frequent stop and start, during this time as well, you require a mechanism where the energy should not consumed during the steady state, or the consumption of energy during this state should be reduced. So how do you reduce? And that will be possible. So when you have a mechanism of a basic hybrid philosophy, and if you observe here, there is a very good video which recently I came across, but now these OEM has removed this OEM right now has removed this video, but I found this as one of the interesting videos, how they explained very clearly about this. They explained about this particular so this was earlier was so yeah. So that was about the vehicle, all the features though they explained. So one of the important features to achieve this idling stop, that is also called as start function. The next other important function is energy recovery through braking. So you might have seen recapitulation of energy, we call it as. So what exactly the energy recovery it will do is, so let us suppose let us suppose you are traveling, let us say the vehicle is traveling with some 80 kmph, and suddenly I have to stop this vehicle. So if I don't have a braking mechanism, how much distance the vehicle will travel? So the vehicle may travel nearly in tens of meters of distance, multiples of tens of meters, and like up, not only tens, it is hundreds of meters up. Approximately, it may go and stop around the 2 kilometers. And if you break it, if you apply a brake, then there may be a chance of reducing to tens of. So you imagine if the brake is not there, then the vehicle to stop from 80 kmph, it will take without braking at least 2 kilometers or 1.5 kilometers to stop the vehicle. But in the sudden situation, what happens if you doesn't have a brake? Then you are going to lose the control over the vehicle and you may hit someone. So one of the important features in the vehicle is the brake. So when you apply a brake, there is an energy which generated at the wheels. When you apply a brake, there is a energy developed at the wheels, that is half mv square, mass into velocity square, that is kinetic energy. So this kinetic energy can be converted. So kinetic energy is mechanical energy. into electrical energy. This kinetic energy can be converted into electrical energy through regenerative braking. Means the propulsion motor will work during that time in the generator mode, and inverter works as a bidirectional converter, so that this energy can be recaptured back to the battery. So that is one of the way of improving the efficiency and reducing the emissions. Then third feature is electric only propulsion. Means your vehicle will be traveling without depending on the engine for certain amount of distance. For example, in a urban case, so vehicle can travel in a minimum distance of 10 kilometers, 20 kilometers, or 25 kilometers without getting an assistance from ICE engine. And fourth point is electric machine assist. And here, electric machine assist is nothing but this is during the starting condition, this electrical machine will assist the IC engine during the starting, and whenever there is a high torque required, then this machine will support. But here it will not. It will not run only on the electric machine. And fifth feature is recharge from external charging or wall box. External charging or on. Okay, so outboard on means here we will use a external charger to charge our battery. So if you have recharging capability, then your battery size will be a little bit higher. So these are the basic 5 features in EV, and all the vehicles may not have all the features. That depends on where your classification of vehicle and where you are segmentizing as a product manager your vehicle. That is another important factor you need to observe. So this one, so if you observe here the worldwide electrification, where and how it is segmented from 2014 to 2025. You can see here fuel cell plus electric vehicle, plug-in hybrid electric vehicle, electric fuel cell hybrid electric vehicle, 48 volt mild architecture, 12 volts mild is nothing but micro hybrid. So there is an estimation that by 2025, 10.8 million of cars will be with mild hybrid and 8.3 will be with full hybrid. 10.5 million of cars with full hybrid architecture. So this shows only mild hybrid and plug-in hybrid and full hybrid takes almost 30 to 35% of the market share, especially the car market share. So there is a huge scope for the hybrid as well as going forward for the electric vehicle in the market. So based on the features which we discussed, how these classification of micro, mild, full hybrid or plug-in hybrid or range full hybrid, plug-in hybrid or range extended is considered. So here there are the 5 features have been listed. The first one is if the vehicle is having only start-stop function, the engine stop and go in the traffic. Then if this is only the feature in the vehicle you have, apart from your regular conventional features, then the vehicle is classified into a micro hybrid platform. So currently, if you would have seen, the old Citroen is classified as micro hybrid vehicle. Second, along with start-stop function, if you can able to recharge the battery with regenerative braking, or if you use the regenerative philosophy in the vehicle, and there the battery size should be at least greater than 24 volts. So there is most probably it is a 48 volt architecture. Then if you have 48 volts regenerative braking, stop with electric motor assist, means whenever the torque requirement for the vehicle, the engine requires some support, that is electric only motor assist. Then if you have these three as the features in a vehicle, then the vehicle is classified as mild hybrid. Honda Insight is one of the example for these classification. Along with start-stop, regenerative braking, electric only assist. If you have electric propulsion, means car can drive for certain time and with electric motor, then you can classify the vehicle as full hybrid vehicle, that is can drive it sometime using only electric motor. As I said earlier also, Toyota Prius is classified as the old Toyota Prius. Very recently released the Toyota Prius is plug-in hybrid. So that is one of the full hybrid vehicle. Then along with the start-stop, regenerative braking, electric only assist, and electric propulsion with external recharging. So recharge the batteries from a wall outlet for extended electric range. Then these five features, if it is consistent in a vehicle, then it is classified as plug-in hybrid vehicle. Chevy Volt is one of the example for this vehicle. And if you see the market share for different companies, like these are the some of the top tier 1 companies which provides the powertrain, means the engine or powertrain inverter plus motor or starter motors like that. So BorgWarner, Continental, Dana, Delphi, Faurecia. Faurecia is now like combined with Hella, so they made it as one of the great Garrett Motions, Schaeffler, Tenneco, and Value. So by 2025, they provide the, like for example, BorgWarner, they provide 70% of power mix of IC engine, 25% of hybrid, 5% of EV. And if you observe, for example, Delphi, they have all four architecture: IC engine, mild hybrid, and EV. Same way Value, same way Garrett Motion. So this is how, and these are not limited to these companies. These occupy the major share, but there are a lot of other companies which are not listed here. For example, Bosch is not listed here, but still they have good mild hybrid, micro hybrid, and they are already in the competition. And there, likewise, there are some maybe missed, but this is how the powertrain mixture, where companies are organizing themselves to move with plug-in hybrid or hybrid electric vehicle architecture. Then, for a design of powertrain, what are the basic requirements? Let us say, if I have to design a powertrain, or if I have to have a powertrain, what is my expectation? Me, first and foremost thing, as a user, as a customer, we may see that what is the performance of the car, means what is the speed it will go, how much efficiency it will give, what is the fuel consumption it will take, right? What is the transmission unit it is having, what is the safety it is having, these all will see. But as a designer, based on these customer requirements, I will see that for 120 kmph, for example, if my maximum speed is 120 kmph, how do I design? What is the maximum torque it is required? What type of machine it requires? Those are we need to see. Second, and when we select a machine or when we select an powertrain, we also need to see that does my selected machine meet the demand of vehicle performance expected by the customer, or my vehicle can carry sufficient amount of battery, or what is the alternate? So these features were part of the powertrain requirement when we select a powertrain. Means basically the vehicle powertrain needs to have it should able to develop sufficient power to meet the demands of vehicle performance. Second is it should able to carry sufficient energy on board to support vehicle driving in the given range. Third is it should able to demonstrate high efficiency. Fourth is it should be able to emit only few environmental emissions. That is the major one along with these two. Then when we talk only with respect to hybrid, then a vehicle should have two or more energy sources as well as energy converters. Then it is called as a hybrid power source or hybrid powertrain based electric vehicle or hybrid vehicle. So in that case, there may be two alternate energy sources, only mechanical based. But a hybrid vehicle with electrical powertrain, that is energy source, energy converter, is called an hybrid electric vehicle. So for example, if you see it as a scenario where I have two energy sources, here I have shown. One being, I can call it as energy source is fuel based, and converter, it can be like your converter can be like IC engine, which converts your chemical energy into a mechanical energy. And second energy source being a battery, and your energy converter is like your mechanical energy or electrical energy is converted into electrical energy. So electric motor drive, I will call. So drive includes all the power electronics as well. Okay. Now let us say this is the kind of hybrid powertrain in ideal case, and here my load is to drive the wheels or to propel these wheels, right? Finally, I have to propel the wheels in the forward or reverse direction. It depends on my requirement. Now, how or what are the possible ways of power flow in this action to move the wheels or to stop the wheels? When stops, what kind of power flow it happens? When during the running, what kind of power flow it can happen? How many resources at a time can it happen? What are these modes of operation? And does all the modes of operation work in all the architectures? So those things we see here. So first, if you observe, there are two energy sources. So if you see here, either I can drive the vehicle only with IC engine. This can be like the first option, and the second could be like I can drive the vehicle if it is full propulsion coupled vehicle. If it is fully propelled vehicle, what means electric only propulsion, then I can also drive the vehicle. Right? This is an option. This is number 2. This could be second mode of operation. Third could be like a combination of both these two could also be a possibility, where third mode of operation depends on the torque requirement or the powertrain requirement. Sometimes your fuel IC engine plus electric motor combinedly should work to meet the requirement of the user. So these are basic first 3 operations, as the layman also we can see. But what are the other possible ways? The fourth operation could be the fourth operation could be, it is like this. If during the braking, half mv square mechanical energy can be developed. So this mechanical energy I can convert back into the electrical energy. This could be my fourth operation. Fifth operation can be I can charge my battery in a standstill condition from IC engine itself. So this could be my fifth mode of operation. And sixth could be like, it is a combination of 1 and 5. It is combination of 1 and 5. Means IC engine can propel the load as well as at the same time it can charge the battery. So that is the sixth mode of operation. Second, 7 could be like combination of 1 and 4. IC engine propels and load charges the battery. That is the seventh kind of operation. Then 8 could be like IC engine charges the battery. The battery delivers power to the load. So likewise, the sequence of operations are possible, and I'm sure I cannot say all are at a time in all the vehicles it is possible. Based on the architecture, based on the vehicle design, based on the converter, it is unidirectional, bidirectional. These features can be seen. Okay, so these operations are again listed over here. First one is powertrain 1 alone delivers power to the load. That means engine only delivers power to the load. Powertrain 2 delivers power to the load. Battery only delivers power to the load. Combination of both load delivers power to the load at the same time. Powertrain 2 obtains from powertrain a load, that is regenerative braking, and that is during the cruising condition or during the braking condition. Powertrain 2, battery obtains power from powertrain 1, that is IC engine. Powertrain 2 obtains power from powertrain 1. At the same time, load as well. So both from powertrain 1 and regenerative braking at a time also it can happen. Powertrain 1 delivers power to the powertrain 2 and at the same time to load as well. Powertrain 1 delivers power to the powertrain 2. Powertrain 2 delivers power to the load. Powertrain 1 delivers power to the load and load delivers power to the powertrain. So these are the modes of operation which are possible in a hybrid electric vehicle. But in which architecture it is possible, we will see next time. So if you see, there are different architectures available in the literature on the hybrid electric vehicle. First one is series hybrid electric vehicle. Second one is parallel hybrid electric vehicle. Third one is series parallel hybrid electric vehicle. Fourth one being the complex hybrid electric vehicle. So in the series hybrid and parallel hybrid are being most popular in the hybrid electric vehicle architectures. Series parallel can also be used as similar, but complex hybrid structure is not right now in the market. And where we will go with series hybrid architecture, where I need to select parallel hybrid architecture, where I need to select this series parallel hybrid architecture. So if you observe the first one, just we will see the operations and operating modes in the upcoming in detailed series and parallel hybrid we will discuss. But you observe here from a perspective, if I give a 10 and same requirement of a powertrain or the load capacity and all other features are same, I need to propel a vehicle which one will have a higher efficiency and why. So in the series hybrid, if you see, there is a fuel tank. Parallel hybrid also having same. You have an IC engine in series. Parallel also you have. Battery you have. You have a power converter. You have a power converter here. You have an electric motor, but you also have electric motor. But there is a difference in this requirement, especially in series hybrid and parallel hybrid. And third one is you don't have a generator in the parallel, and you don't have a mechanical coupling in the series hybrid. And both the sides, the motor is going to connect to the transmission. The motor is going to connect to the transmission unit. You can see. Okay. So now, if at all, if I have to design a vehicle, you can observe here series hybrid. Overall, the machine electrical motor is connected to the transmission. Means it should have a combined kind of power. What IC engine correct means, let us say if I have to run a 100cc motor, 100cc engine, then I should be able to convert this much power energy into mechanical to the electrical, then electrical to mechanical. For that capacity, I need to design a power converter. Means, first of all, here it is doing, you are observe here, IC engine converts mechanical energy, chemical energy to mechanical energy. Then this mechanical energy converting into electrical energy. Then this electrical energy is converting into mechanical energy. So there is a double conversion of energy is happening in the when it is from the IC, the series hybrid. Whereas here the motor requirement will be smaller because whatever the capacity according to the battery will design the motor and power electronics because it is independent of IC engine. Means IC engine separately propel, electric motor as the independent propulsion. Here motor is, it can propel independently based on battery, but if it has to propel with a larger torque, then it should depend on the IC engine. So that is one of the things. And here the capacity of the motor and generator in the series hybrid is higher than the motor which presents in the parallel hybrid architecture, though the same power rating if it is. But the complexity in the parallel hybrid is you have an extra mechanical link over here. This mechanical link creates a complexity in the control aspects. Means switching between your IC engine to the electric vehicle, electric motor, or electric motor to IC engine, that is a stringent and complex control is required. Then, so now the motor size and is less in parallel, motor size in generator size extra is required in the series hybrid. For a same capacity, if I select a series hybrid, if I select parallel hybrid, then I may have the efficiency in the parallel hybrid will be high, and the overall vehicle size will be reduced in the parallel hybrid. And specifically, why we can go or prefer series hybrids, it has a good control as well as the heavy vehicles may be like commercial vehicles can also use this kind of architecture. Then series parallel hybrid, its name itself says that it is a combination of both. However you want, you can work either is a parallel independently without the generator engine, or I can also work independently with battery, or I can work as a combination. So the combination of series and parallel is series parallel hybrid. Complex hybrid is, it is a pictorial representation very similar to series parallel, but there is an extra motor, like you observe the two electric motors over here. So you need to see overall the capacity is increasing and it is a structure itself complex. Currently it is not the market at all. Okay. So we'll discuss in detail what is each component and what are the modes of operations possible in the upcoming slides. So you can see here the dark lines indicates the electrical power, the single line indicates the hydraulic, and double line indicates the mechanical lines. Okay. Now you observe this is how a pictorial representation of a hybrid architecture can be there. You see here engine, generator, rectifier, inverter, motor, and transmission. Here it will go for a differential and axle. And from charging in battery, DC converter. So what is the basic functionality is, so engine which converts chemical energy to mechanical energy. Then generator converts your mechanical energy to electrical energy. And here already electrical energy, why rectifier is required? Rectifier is required because generator produces energy in AC, but my motor requires some control. So I need an inverter to control. For an inverter, input is a DC. So I need to convert this AC power into a constant DC, direct current. We'll see what are these in detail, what is AC, what is DC, how do you measure all the parameters. Then this DC will be converted into AC with the requirement is like high frequency AC to control this motor. So again, motor control your electrical energy to mechanical energy to propel. And here in the transmission, you may have a gearbox to reduce the speeds, to adjust the speeds accordingly. Then, if that is one part, and you also have you may have a DC link capacitor over here to stabilize these constant DC voltage. Then from here, the other part, charging. So generally the charging unit, it may be converting into AC to DC. If it is onboard charger, then if it is onboard charger, then you will connect to an external charging outlet of AC. Then battery, which actually stores the energy in terms of chemical and produces the output in terms of DC. Again, it is like a electrochemical plant. Electrochemical. Then the output of the battery is a DC, but this DC will be varying with like this. Generally, battery will be rated for a nominal voltage, but battery will have a peak like this. Maximum peak, then you will have a minimum. Any battery if I take for a 48-volt battery, if I take the minimum voltage will be like 30 volts, maximum voltage will be like 48 if I completely charge. So to convert this 48 into 30 into 48 and 58 into 48, I need a converter which can convert 38 to 48, 48 to 58 to 48. So, and to meet this constant requirement of DC link, I need a DC-DC converter. So this is how all these basic component requirements present in the architecture. So if you observe how these all components well placed part of series hybrid similar. So again here the most important thing is motor should meet the torque speed requirement. That is the one of the very important feature. So now coming to the operational modes, what are the possible operation modes in this series hybrid? So as I told you, engine can convert chemical to mechanical, generator mechanical to AC electrical, rectifier AC electrical to DC, then DC electrical power will be converted by the motor controller into AC. Required power required for the electric motor converts into electrical energy to mechanical for the transmission and differential. So the basic operations here could be, first could be like, one is converting these. This is the one way of propulsion. The other one is like, that is called pure IC engine alone propulsion. Then pure electric only propulsion means the energy will be flowing from a charger will charge the battery, then battery will give the supply to the DC-DC converter. DC-DC converter provides to the motor controller drives the traction motor. So that's how the second operation. Third operation could be a combination of both from the engine as well as from the battery. And fourth operation could be like you recharge the battery. If it is you can also charge the battery from engine as well as from the charger. There are two ways of charging. Fifth operation could be that you get the regenerative energy from the battery, vehicle load. So these are 5 possible modes of operation which you can see in a series hybrid architecture. But how does these functions? Who will give these instructions? So the possible modes of operation and the most important one are these all are power electronics component, including this motor. Okay, motor is an electromagnet, generator is an electromagnet, but the input is there is a connection with the electrical. So I just made it into the electrical or power electronics. So these are the possible modes of operation. Pure electric mode we have seen from the battery itself. Pure engine mode, combination of both, regenerative, charging from engine, charging from the battery. So that's what here it is. Hybrid mode, pure engine mode, engine traction and battery charging mode. That is through the I can say through the engine itself. Engine will drive as well as charge the battery. Then regenerative braking, battery only charging mode from external or battery charging mode both by the engine as well as from your I can say this one outlet output charger. So, but how do you control it? That is more important. How these all instructions will flow. So, for example, if you see it is a command, let us say automatic transmission, then you will have in the vehicle only brake and auxiliary acceleration, right? In a manual transmission, you in a regular conventional cars, you might have seen 3. It is A, B, and C: acceleration, brake, and clutch. So in EV or hybrid, let us consider an automatic transmission where you have 2 inputs, acceleration and brake. When user gives either an acceleration or a brake, the first instruction will go to the heart of the vehicle or the brain of the vehicle, that is called as vehicle control unit, that we generally term it as, in the industry terms, it also termed as VCU. VCU will get the appropriate command from the driver. Based on that, if it is an acceleration, first VCU will check the information, what is the analyze, what is the torque requirement, and it will first communicate or get the information from the battery, that is peak powering source is nothing but battery. Battery provides the information like state of charge, state of health, what is the temperature, and all other information. It will be communicated through a CAN, control area network. CAN is nothing but, this is the communication protocol used to communicate between the vehicle control unit to battery management system. So if vehicle controller sees that battery is having enough SOC, state of charge, means the remaining power, remaining energy to drive this motor, then vehicle controller sends the information to the motor controller to get the power from peak powering source and drive the vehicle in only electric only propulsion. If not, it will see that what is the amount of power required from engine controller, then it will assign the engine controller to provide the required amount of support to this battery to drive the motor. And in the third case, if at all battery doesn't able to support the SOC, then vehicle controller asks engine controller to drive the vehicle in the pure engine mode. And always it takes the feedback, the speed feedback to the vehicle controller, as well as the motor feedback to the motor controller to have a control on the speed. Overall, whatever is the instruction, it will go, the motor control will be done in the inverter. And let us say if the command is brake, again there is a two instructions it will go. First instruction is vehicle will ask the motor to reduce the speed. So ultimately the motor controller will have to reduce the speed, or means it has to reduce the power input, thereby it can reduce the speed. Second one, it will go to the brake controller, so that this brake controller actuates the brake actuators, and when it actuates the brake actuator, there is one more action the motor should do. And when the brake is happening, motor should go into the generator mode, motor controller work as a rectifier, then charge the battery. So that is the third operation it will perform. So overall, whatever the commands we give, that should work. And here if you observe, all the signals are at 3.3 volt or 1.25 volts or 5 volts, depends on the microcontroller which we select. And this dark line is majorly the high power electricity flows, and double line is the mechanical interaction. So this is how a series hybrid electric vehicle control and operations it will perform. So I will stop here for today. If you have any question, I'm open. Otherwise, we can close it.